In this video, I will show you how to build your very own ME-6 droid from Star Wars. The ME-6 droid, also called the mouse droid, is a cute maintenance robot zipping about on Imperial starships. It's an easy build you can complete in a day or two, and the parts should cost you less than $50. I will cover how to get the print files and the electronics, how to assemble the mechanical parts, how to wire everything together, and how to write the code to get it to drive. So let's get started. Here are all the parts you need. I've included a bill of materials in the video description. You can find the needed electronic components on Banggood or Amazon. All these parts here are the 3D printed plastic parts. The robot itself is black, but you can use other colors for the insides if you prefer. The most important electronic components are an Arduino Nano for the brain, a motor controller, a Bluetooth module, a small MP3 player with a SIM card for sound, a geared motor, a speaker, a voltage regulator that outputs 5 volts, and in addition you need some small bearings, some wires, and some M2 and M3 nuts and bolts. To download the print files you must be a patron of Mr. Baddeley. It's a small monthly fee and will give you access to many more robots you can build. Once you're signed up, you can find the files in a folder called Mini Mouse. I have chosen to print my mouse in PGD with a 20% infill and a layer height of 0.2 for all parts without any supports. For the wheels, you can print them solid, or as I have done, print the tires in a soft filament called TPU, which makes it drive better on a hard floor. Let's assemble the mechanical parts. The print files come with a good set of instructions and it's pretty easy to put together. I recommend waiting to mount the electronics until you have tested that each of them work on its own. Before I put all the electronics together, I always test each component individually to ensure that it works and that there are no loose connections. I added code to this GitHub repo to test each part on its own. Simply connect the component and upload the test program to the Arduino. You can use breadboard wires like these one here to connect everything. Since it's a bit tight in the robot, I've chosen to shorten some of the wires and solder a splitter on the ground and the power wires. Here's a diagram that shows how everything should be connected. Now let's test that each individual component works as expected. To test the Arduino and that you can upload code, you can use this simple blink code. It will flash the onboard LED in a distinct pattern so you know your Arduino is working and running your code. You upload code from the PC in the Arduino development environment by choosing your board and pressing the upload button. You can now see the LED is blinking, so all is good. The UBEC is used to convert power from the battery to 5 volts the different component needs. This one has a small dip switch where I can select output to 5 or 6 volts. To avoid frying anything, I always do a quick test with a voltmeter to ensure it works as expected and only output about 5 volts. This motor controller is a very popular one called MX1508, and you can control the speed and direction of up to 2 motors. You need a motor controller since the Arduino cannot supply enough power to run a motor on its own. You connect 5 volts from the UBEC here, the motor here, and the control signal from the Arduino here. IN1 and IN2 pin are connected to analog outputs on the Arduino and together control speed and direction of the motor. When you run the test code, you should see the motor turning back and forth at different speeds like this. To play sound, we use DF Player, which is a small MP3 player with a built-in amplifier. You can connect it as a serial device if you want full control, but for this small build you can just briefly ground pin IO2 to play the next sound on the SIM card. You connect the speaker to these two pins, power and ground here, and the signal to play a sound here. One quirk of this module is that it may sound bad unless you ground both ground pins or solder a wire between the ground pins like I have done here. The files must be placed in a folder on the SIM card called MP3 and the files must be 4 digits. To play the next sound, you briefly ground IO2 pin. You can adjust the volume by grounding IO1 for lower volume or IO2 for higher volume for a few seconds. The servo we mounted in the robot is used for steering. It just needs power and one control pin on the Arduino. When it's working, the test program will turn the wheels like this. To control the robot via Bluetooth, we use this HC06 Bluetooth module. It can both receive and send data using the RX and the TX pins. Receiving data from a robot is useful if you want to add sensors to it. The RX pin on the HC06 can only handle 3.3 volts, so you need to make a voltage divider like this one with 2 resistors to change the 5 volts from the Arduino pin to 3.3 volts the RX pin requires. When the module is connected, it will be blinking fast until you have established a connection. The default password of the HC06 is 1234. To test sending and receiving data with the module, I like to use a serial app on an Android device or PC. The HC06 module do not work with iOS devices due to different Bluetooth protocols. You connect the HC06 in Bluetooth settings on the Android device. Then you can upload the sample code to the Arduino. Here you can see the serial monitor receiving a signal sent from the Arduino via the Bluetooth module every 5 seconds. If I send a message from the serial app, it's printed on the Arduino serial output. So now we know that the Bluetooth module is working as it should. Now that we have validated that all electronics are working, we can put it all together. For a small robot like this ME-6, you can attach them with double-sided foamy tape like this. To control a robot, I like to make my own mobile app in Unity, but that's a topic for another video. If you just want something simple, there's a mobile controller app called Dabble, and you can use the code provided with the print files from Mr. Batterley. In the next section, I will walk you through the code required to control the robot from any Bluetooth device and any programming language you prefer. If you connected everything like I described earlier, you can just upload the ME-6 file to the Arduino and it should work. The Arduino code has a main loop that listens to Bluetooth input and then activates the needed hardware like rotating the motor and the servo or playing a sound. To make the robot drive continuously, you need to send a drive command regularly or it will stop. For moving robots, I prefer this approach to ensure it will stop moving if Bluetooth connection is lost. You make the robot drive by sending serial commands to it. Here's how to turn the steering, drive forward and play a sound. Now you know how to build your very own ME-6 mini mouse droid. Thank you for watching. This was a reasonably easy build where you learn to use some of the electronics that are used in many projects. I will soon be posting additional videos where you use these skills to build more advanced robots. If you found the content valuable, consider subscribing so you get notified when I release new videos.